El-Battani. Born in 858 in southern Turkey, El-Battani made accurate astronomical measurement a personal obsession.
The story goes is that El-Battani used to observe on this mountain here and that in this observatory.
Over 40 years, from 877, both here and in the town of Raqqa, El-Battani's great project was to work out as accurately as possible the length of the year.
This is a copy of the original manuscript.
Okay.
So I'll show you the chapter at which he explained the length of the year. Okay? The chapter 27. So he first started here by citing the ancient values of the Egyptians and the Babylonians, right? And he gives the length of year.
Their estimate of the year was 365 days, 6 hours, and just over 10 minutes. To improve on this, El-Battani used his ingenuity and a device like this, an armillary sphere. He used it to measure how the length of shadows varied over the course of the year. With this information, he was able to work out the precise day on which it's both light and dark for exactly the same time, the so-called equinox. And he repeated his measurements over the course of 40 years. Now, here's the clever bit. He examined a Greek text that was written 700 years earlier and discovered the precise day on which its author had also measured the equinox. He now had two vital pieces of data: the number of days between the two observations and the number of years. He divided the first number by the second to arrive at an astonishing result. A year is 365 days, 5 hours, 46 minutes, and 24 seconds.
And he gets the new number, which was only 2 minutes of the modern observations.
2 minutes?
2 minutes
so
of only.
The length of a year to an accuracy of just 2 minutes.
Exactly, the one he calculated.
What's astonishing about the accuracy of El-Battani's measurements is that he had no telescope. He used an armillary arm, his naked eye, and devices like this, an astrolabe.
So you move the pointer and you move this disc with it to point towards the North Star. Then these small pointers here, they will give you the location of the rest of the stars and the planets. Okay.
Despite this, among his many other observations is an incredibly accurate figure for the Earth's tilt of just under 24 degrees, about half a degree from the figure we now know it to be. And he didn't stop there. He measured variations in the diameter of the sun to such accuracy that it led him to an astonishing conclusion. This distance, the furthest point the sun reaches from the Earth during the year, known as the apogee, actually changes from one year to another. Also, his tables showing the position of the sun and the moon, which is what Copernicus refers to some 600 years later, set a new standard in precision and accuracy. So El-Battani and his fellow Islamic astronomers were clearly good observers. But so what, you might ask? Well, the answer is that their observations began to suggest to them that the prevailing Greek theory that described how everything in the heavens revolved around the Earth had some serious flaws.